Nope. Steam. No Man's Sky Fractal update. Who knows? Oh, right. Last played today because yesterday at like 5 a.m. is today. And the Unity prompt for full screen will happen after I launch it. Okay. Man, the first time I played this, I was like, wow, how could anybody like start a new world? And now I'm like quite far
Let's
along.
start a new world.
Yeah. And I'm like decently far along in this world. Okay, so how many of these can I support at once? A fucking lot, apparently. So 3 mechanical parts by 12 is 36. Mechanical parts is like 100. Steel bars is 300 iron. Okay. Right, and then this is in service of making carbon for aluminum processing. So that's down here. And then these go into factories. I'm gonna make polymer bars. All right, and so each of these is 90 carbon, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So really, I only need one of these machines, or I need way more of these. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Polymer bar. And then factory. No, assembler. These make 30 per, so there's enough for about 6 of these, theoretically. Okay, so I'm actually going to run a test here, which is going to involve me stepping away for a little bit. But basically, if you... So I'm just going to think this out loud and let me know if this makes sense to you. So these... Basically, I think there are hidden rate limiting factors in this game, one of which is very significant, is the amount of time and like how things propagate down lines of conveyor belts like this. So each one of these machines is making 12 carbon per minute, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of these making, so that's 96 times 2 or whatever. So one of these rows is 96, and these factories take 3 carbon 30 times per minute, let's say. So they will consume 90. Each one of these has 96 available to them. So they should theoretically, and you can see it pausing here, right? They should theoretically be manufacturing 60 polymer bars. They should be at full capacity, right? Like we should be transferring items to them at max speed, but they can't get items at the max speed. So they're being rate limited, and as a result, they can't, like, these factories will never get enough resources, even though in total, oh wait, this is perfect. 5 times 12 is 60, which is the exact output of these machines combined. So 30, 60, and then 12, whatever, 24, 36, 48, 60. So theoretically, these two should be able to feed these, but they can't for 2 reasons. They can't get fed fast enough by this one belt, and they won't be able to feed stuff, I don't think, quickly enough on this belt. And I'm actually not sure which is the limiting factor. So that's an interesting thing to think about when I get back. So I think what'll happen is, so I'm interested, there are a couple of things that can happen. Once this hits 40, these factories will not be able to output directly to this pad anymore. And I think what happens at that point is not that it can't output anymore. I think they will output to this one, but I'm not sure. So I want to see what happens when this fills up, and I can actually make that happen a little faster. Yeah, so this will just never overflow, or we'll see. You know, I said I was gonna step away, and I'm not doing it. It's not happening right now, I'm noticing. At least I'm like zoning out though, as opposed to doubling down. Man, oh my god. JavaScript, and oh my god, this isn't even just JavaScript, just the internet. It's so much easier than it used to be. And it allows, on the plus side, it allows me to deploy applications on scales and with speed that I would, and with features that I would never be able to do 10 or 20 years ago. The only downside is that the possibilities bring with them personal expectations. Like, I expect that I'm going to make something that can do, like, you know, some fraction of what is actually possible on the internet today, and it's so powerful and complicated that it's just overwhelming at times. Okay, this is full. This is full. Okay, so what's happening is that these are filling up entirely, and the production is actually pausing. But when that happens, do these ever get to a point where they stop stalling? So we're gridlocked 3 down. And I think we can get, I'm not sure how far down we can get gridlocked, actually. And yeah, I was correct. So we're seeing the little drones will actually jump from 1 to 2 away.
I gotta. Shit, it's 2:30. I was gonna say I gotta log off and get ready for bed.
Cool. All right.
Actually.
Well, maybe I'll see you tomorrow.
Wow. Yeah.
Yeah, you
I'm
thought
trying
you.
to fix my sleeping schedule because I've been staying up late reading.
Yeah. All right. Well, I'll be around in the morning.
You let me know when you're ready to face the music again.
Yo, it's gonna be irresponsibly early. What I'm gonna do is go get. I'm gonna go to the grocery store and get a thing of cold brew coffee. Not because I need it, but because it's delicious. And for some reason, drinking coffee has a little bit more predictable of an effect than Red Bull. I'm not sure what it is about it, but I guess it's not important. Oh, this is very interesting. Okay, so we only can gridlock up to the first 4 or so. Yeah, and these are no longer hitching. Okay, they are hitching. Okay. But not as much. Okay, that's very interesting. I mean, I don't know what to do with that information, but yeah, that's okay, good. Basically, I am happy about this because it means that I didn't just so the last time I played this game, I got quite frustrated at the fact that I wasn't understanding what the actual rate limiting factors were, and I wasn't sitting down and taking the time to actually make sure that the systems weren't working in the ways that I thought they weren't working. And the bandwidth of these 2 factories is absolutely limited by the fact that there's only one of these pads feeding them. But it's more complicated than just that. And I'm not going to bore you with more details than that. But it's complicated is sort of the takeaway. I mean, you haven't left yet. So basically what's going on is that if you look at this drone okay, let me slow it down. Okay. So this drone, there's a little landing pad right here.
Yeah.
And you can tell that the drone that belongs to this pad is very occupied because you never see it landing here. But you can tell which one belongs to it because it's, sort of centered around there. But you saw it. Yeah. You see this pad has a range of 1 tile, right? So you would think what would happen is this drone would grab something from this tile, move it to this tile, and then move it to this tile. But
just the middle part.
What happens instead is that it will grab stuff from this pile and jump all the way to here. And it will also grab stuff from this machine and jump all the way to here. And from this machine and jump all the way to here. How it schedules and prioritizes those various things, I don't know. But something else that's very interesting and destructive about the depot system in this game is that this pad, even though from a logical perspective, these pads are moving in this direction, and therefore this is a requester for this, and this is a requester for this, and this is a requester for this. Yeah. That's not actually how it works. This is a requester this is a requester or a supplier based on the relative amount of resources in the tiles that are available to it. So like this will actually feed carbon backwards if I empty this one. So if I empty this, you'll see this drone works counterproductively, and then there's a knock-on effect and all of them work counterproductively, or like they can work counterproductively. So this basically means that some amount of the time this drone will be spending time moving something from this pad to this pad. And that is heinous.
Yeah. Alright, I'm gonna sign off now and go brush my teeth or something. I'll
All right,
speak
cool.
to you tomorrow. Ready to do it again.
Yeah,
All over again.
I'll be ready. You can depend on that. All right, have a good one. Thanks for all the help. All right, peace. So something we're seeing here is this depot is taking priority over this factory. So an effort is being made to fill this fucking depot up instead of putting stuff into that factory. So we actually get less. Yeah, so this is very interesting. So I don't know what the tile priority order is. So right now, like it seemed when I put this here, that this one filled up, and it may just be because this one can put shit here. I'm going to assume that there is no hidden priority. Although this is really making it seem like there's a hidden priority. This is really making it seem like we go 1, 2, 3. So rightmost first. So this one's filling up. This one's 100% fine. This one is struggling a little bit. This one is fucked. Okay, 1. I'm actually going to watch. So this is the only drone capable of putting stuff on there. 1. Whoa, 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 whoa. Oh my god. Ugh, I wish you could freaking rotate the camera. 2. Middle. Left. Middle. Left. Middle. Left. Middle. Oh my gosh. Left, right, middle, left, right, then middle. So right, middle, right, middle, right. No, so it went left there at that one thing. It might have already been scheduled somehow. Middle, left, okay, right, middle, right. Middle, no, right, yeah, middle, right, middle, right. So sometimes it'll go left after it's like after like 10 times or something. It's absolutely prioritizing right. So I'm gonna assume that so I don't actually know, but oh my god, Jesus Christ, what does right even fucking mean in this game? Like, it's a hexagon. I mean, I didn't come here to not do science. Okay. These are capable of draining. Oh, fuck this. Okay. Okay. 3, 4, 5, 6. Is it being attached to another provider is interfering? Okay, well, it goes counterclockwise. That much is apparent. Okay. I am going to. I think for my purposes, I only need to understand that there is a prioritization. I don't think I need to know the prioritization. Like, in order to make progress. Okay, I gotta stop making things like this. I'm gonna let this run dry, and then when it does, we're not gonna make something like this again. Okay. So 1, 2, 3, 4, 60. 1, 2, 3, 4, 60. So these take 90. Okay, so 1, 2, 3, 4, 60. 1, 2, 3, 2, 3, 4, 60. 2, 3, 4, 60. 1, 2, 3, 4, 60. So 60 and 90 have a GCD at 90 times 2, which is 180, which is 60 times 3. Is it an LCM or GCD? I don't remember. Anyway, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So that is actually the right amount. So exactly the right amount of carbon is theoretically being produced right now. But I think that it's quite inefficient. I actually think that you sort of have to get these in like in little pods. So let's try a different approach. Okay, so let's make that a carbon pad, and then how can we get... So I want 6 of these, or I want 9. Well, I want 8, right? So 2, 3, 4, 5, 6. So 5 is 60, 72, 84, 96. So 1, 2, 3, 4, 5, 6, 7, 8. And then this one can divide by 2. And then 1. So I don't want to divide all of them by 2. Or do I? So these ones, because these will have some unknown prioritization. So if these are 1, okay, so these are, let's call these 6. So I think we can get, yeah, we can get exactly to our target with 6s. So 12, okay, 8, 12, 16, 32, Jesus Christ, 12, 24, 36, whatever, 5 is 60, and then 66, 72. Okay, so if we go here, then we have 1, 2, 3, 4, 5, 60, 72, 84, no, 72, plus 6, 78, 84, 90. Okay, so 1, 2, 3, 4, 5, 6, and this. Okay, so this is enough. But is it actually enough? So this is exactly enough. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 120 plus 60 is 180. Wait, isn't? Yeah, it is. 120 plus 60 is 180. And 90 plus 90 is 180. So we're still struggling. There is no higher density way to pack these. Sorry, let me rethink that. What is the highest density way to pack these oxygen guys? Okay, so first off, we have Mark IIs now. So let us make a polymer factory here, and you can stay operational like that, and you'll need 1 fewer. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. All right. I mean, let's give myself some more space. Two, 3, 4, 5, 6, 7, 8. And then in this case, 9, 10. So yeah, I think you want to overstuff the ends on a configuration like this, and it may actually be better. So with this, we have 2 skips. I think you want as many skips as possible, but I'm not actually sure. Okay, so this is our target. So if we put a base here, then we can jump. All the way here. So 1, 2, 3, 4, 5, 6. And then it can also jump from here, 7, 8. So this configuration seems to work pretty well. We're definitely not rate limited on this side. And we may or may not be rate limited on this side. Here, I don't think that we're experiencing rate limiting here. Oh, did I see a hiccup? So this means that the throughput an uncomplicated throughput of a single depot is at least 90. I see the drones down every once in a while. So the first question that pops into my head is, can we supply more than this? Okay, so the first thing to note is that I don't think that we can get up to 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 spaces, the tiles that are within range. So this is the maximum number of tiles that this single depot can hit. So let's so we're forced to jump to 2 at this point, no matter what. So we're at so a full hex in this, a full 3x3 hex is 1, 2, 3. Or let's just get the basic, whatever they're called, the like triangle numbers, but they're hexagon numbers. 1, 2, 3, 4, 5, 6, 7. So 1, 7, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we do have more than 15. So 19, no, 17. So this is 1, 2, 3. Oh my God. 1, 2, 3, 4, 5, 6. Is there an easier way for me to calculate this? Is there like a square in here hidden or something? It's the calculation for how many, or like for the area of a hexagon based on its edges is probably a terrible bit of math. So I just need to remember 1, 7, and then I think this is 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 plus 7 is 19. Okay. 1, 7, 19. So one depot has access to 19 squares, and I need 15 of these. So we have 19, 18, 17, 16, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So now this can go to up to 2 polymer plants, which can go like this. And we will get rid of this factory. Okay. Basically, one of my goals in this playthrough is to minimize the damage to UPS. And, you know, obviously that's, these systems are not optimal for that. But I'm going to get better at that as the game goes on. All right, so this is a balanced oxygen, or a balanced polymer creator. So this is creating 60 polymer. So to create 60 polymer, you need a 3x3 hex. Or a, what do I call this? We'll call it a Mark II hex, I guess. And there is more than enough room for an output. I'm going to... Oh, right. Well, the city doesn't have to grow. Let us make an assembly plant that makes landmark towers. This is still not receiving adequate polymer bars, which is difficult to explain. These are not supply limited. So yeah, so I think this would have to back up to like an unfathomable degree. All right, and then, okay, so I want some amount of modularity, but I also want compactness and efficiency, right? So I can make, so it takes 19 tiles because we need an offloader. So it takes 18 tiles, I guess. No, 19 tiles total, but it takes 18 adjacent tiles, I guess, to make 60 carbon. So something that we could do, since this takes 5 inputs, is do this, and then I think 2, 3, 4, 5. Okay, so that works. And then let's upgrade this to a Mark II. And let's actually move it here. So this is then 2 of that. Okay, so we're actually gonna do this. And then we'll just assume that this is an adequate way to supply from the aluminum side. So ideally we would have both, like basically both of these within the same 5 tiles. So this can go here. And this can go here, and then we can get rid of that. And if I wanted to expand, I could expand to here, and that's it. So I could have 6 total. I think if this pad was here, you know, if this pad was in the center, it would be more efficient. I just don't want to go bi-directional right now. In pursuit of maximum density in the future, I will have to do that type of thing, but I don't have to right now. Okay, so wow. So I could start doing some experiments over here as well. I do want to make reinforced concrete. That might be as many of these as I need ever, and I can always make more. Alright, so I'm going to be shipping steel, which is 3 times the density of iron. And there is nothing that takes iron ore, so iron should always be manufactured on site. Anyway, so we have, let's just make, let's see. Let's get an assembler, a set of assemblers down, and then make a target based on the number of assemblers, like on a modest number of assembly plants. Okay, so I'm really not going to try and place them too close to anything in particular. Okay, so it's actually a factory. Reinforced concrete. Reinforced concrete takes concrete and steel bars. So, and it consumes 30 steel and 30 concrete. So, let's start with 30, 60, or with 180. So we're going to offload steel from here at, oh, okay, never mind, at 90. So we're going to make 90 reinforced concrete, which will take 90 concrete and 90 steel. So one of these, so I need 6 factories to produce that. And the thin air ideal is obviously not possible here, but it's not as far off as you might think. Okay, so now we're actually getting towards like OG density problems. Okay. These colors aren't that different, are they? Okay, so in this configuration, we'll have a stop coming in, and then we will, so I think we should have 2 stops. Should have a very short bus route, because it's much more realistic that we will be moving concrete. Okay, so these 2 squares are within 2 units of this many places. Correct? No. This many. That is correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so that's much more reinforced concrete than I was planning on making. And I'm not positive that I can feed all of that. One factor to consider is that this needs fed. Okay. So we can build like this. 1, 2, 3. Ah, correct. Okay, so, oh, actually no. Okay. Okay. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we would max out at 10. But at first, oh no, because these stops can't directly load. So what we need to do is move the stops to here and then unload resources here and here. So we'll do concrete and we'll do steel bar. Okay, so 10 is the maximum number of machines for this setup. And we need to get reinforced concrete out. So this is where there's some balancing work that actually doesn't need to get done here, so never mind. All right, so we need equal access to all of these machines from 3 pads. Okay, so back to the drawing board. I'm pretty sure that the center is the max, or like placing the whatever. Pretty sure this maximizes surface area. 1, 2, 1, 2, 1, 2, 1, 2. Yeah, 1, 2, 1, 2. And this is 3 tiles from there. This is 3 tiles from there. Yeah, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9. If we need to load something in, then we take that out. We take... Oh, no, because these will load from 2 away. So the stop can be here, here, and here. So they can be stop, stop, stop. Okay. Very interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be making 180. Okay, I can do that. We can make 180 concrete. Okay. Steel bar, and then we'll make this one reinforced concrete. Okay. 3, 1, 2, 3. All right, so steel will come in here. Sulfur will come in here, and reinforced concrete will come out here. And this will take reinforced concrete, and then this will get upgraded to a tier 2. So we're gonna see what the maximum throughput of those is. I don't have enough fucking trucks. Okay, do I have any perpetual factories left? I mean, let's see. Okay, no, we have no perpetual consumers. So this is theoretically a reason to slow down. I think what I'm going to do instead is just go full speed ahead. Ah, we are no longer manufacturing these. Okay. Okay, so now I have an opportunity. I want this stupid reinforced concrete, which means that I need this. Okay, so we're just going to balance the trucks. All right, so we'll have steel bars, and then we'll finish this experiment later. 60, 60, and then we just will pretend that this is a bus stop. No, we won't. We're going to have a bus stop here, and it's going to get loaded from here. Okay, so this will be concrete, and then okay. Okay, so we don't get to run that experiment quite yet because I want to run a different experiment. Okay. This takes an obscene amount of mechanical parts. So 1, 2, 3, 4, 5 is 60 times 3 is 180. What is this route even capable of moving? Okay, we're going to scale this back until it's actually transporting a number of things that, you know, we could actually produce. And then this is 1, 2, 3, 4, 5. Okay. And then we will upgrade this one to a Mark II. And then I suppose I can make this dense. Change destination here. Wow, really? Change destination here. Okay, 183. And this will be steel bar? No, it'll be mechanical parts. Okay, mechanical parts are very low density. But we need 180 of them. What the shit? Okay, great. Objective, increase the temperature by 1 degree. Okay. Yeah, I can do that in a bit. And then we upgrade this to level 2. And then we make one of these. And this actually goes here. Okay. Boop, boop, boop. Boop, 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 boop. Jeez, this is so fucking cringe. I don't need any of this. Okay, be gone. Okay, well, how much do I need to make? I want to be making 180. Oh, well, this is very interesting. 73, 61. So this can allegedly take 61 reinforced concrete out, but somehow okay, no, we're not over capacity. All right, so current notes. This is not balanced, so there's actually not much to say. Okay, well, that was fun. Okay, so we need 180 worth, which means we have 950. Fuck me, man. How many machines? 15 machines? Okay. 180 over 2 is 90. 90 goes into 3 3 times. 3 times 2 is 6. I need 6 of these machines. Okay. Let us begin. Factory. One. This will be steel bars, and then this one. Steel, no, factory, steel bar, 1, 2, 3, 4, 5, 6. And these are all within 2 of this tile, where we will have a very short bus route. I'm not even going to have a bus route. Okay. And then there will have to be an iron pad here. And then we will need twice this many extractors. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12. Okay, so this can reach 1, 2, 3, 4, 5, 6. It could reach 7, but this is gonna be difficult in general. Okay, so this is the fewest number of hops. Okay. So I want to see if this is a reasonable way of loading these machines. So it's not yet. I'm actually doubtful that I'm doubting that I've done the math correctly. Ah, I have done the math incorrectly. So these will consume 3 times as much. So 3 times as much as I estimated. So we need output of 36 of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Okay, so 36. 35. 34, 33, 32. 33, 34, 35, 36. Okay. So I will be interested to see whether or not these get overloaded. So it seems like these are overloaded. So we can almost transport enough. Does this help throughput or hurt throughput? So it's unclear to me if going sort of back and forth helps throughput. Another possibility is that we can have a setup sort of like this. So now we're funneling through here. And that's gonna be insufficient. Okay, so once that balances, then we'll be pulling from here. Now, why does it seem like this is wildly... Oh, okay, because we don't have nearly enough buses to take all of it away. Okay, so really I haven't solved my problem. Also, we need another mine for high-tech parts to make buses. I suppose I can currently divert some resources, and this will be mechanical parts. And then these will make mechanical parts. And then we will have an assembly plant that makes buses or trucks. So these make 30 per minute. These consume 12 per minute. No, 24 per minute. So 3 of these will consume oh my god. 24, 48, 72. Yes, okay. And these are taking in 60 of the steel bars, so there should still be enough steel bars. Okay. Okay, 90, 90. 90, okay. Very interesting. Okay, a mistake I made way earlier in my playing that I will not make again is not just demolishing infrastructure. Okay, we need 73 oxygen. So let's call it a 3x3. Oxygen. Oh, and this is just straight. Yeah, so this will just be the max density. Okay. So we want an atmospheric generator. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. 3, 6, 9, 12, 15, 16. 16 times 12 is more than... Oh, huh. Interesting. What happened? Waste disposal insufficient. Oh, we popped over to the next city size before I have garbage disposers. That's pretty funny. So there like are no rewards at all to making your city bigger for a while. So to save UPS, we're just going to let the city rot. And I'll leave this here. And you know, it'll be fine. The city will maybe contract, but that's totally fine. Okay. Man, I find it pretty cringe that I was making or that I was transporting concrete or sulfur instead of concrete at all last game. Oh, I suppose we can turn this back on until we run out of recrete here. Okay, so we have a goal to increase the temperature by 1 degree. I think I can do that. Yeah, right, so our city exceeded 1,000 and then, or yeah, so it's at 1,000. Yeah, that's okay, it can decrease. I don't mind. Okay. We have greenhouse gas generator, which requires high-tech parts, which require a factory. High-tech parts, 2 aluminum, 1 polymer. Okay. All right. CD Terraform. Okay. Code. I guess this is a resource definition. Okay, so high-tech parts, and then we're defining So it's going to take in aluminum bar, 2, and steel bar. No, it's gonna be polymer. Man, they are called polymer bars in here, aren't they? Okay. Bars. Okay. And it's going to make high tech, no, high, oh yeah, high tech parts. I think it makes, oh, so it makes multiple high tech parts, right? Yeah, so it makes 3, and annual production is 90? Holy shit. And high-tech parts. Okay, so high-tech parts need to be made at the source. Oh my god. Okay, so, and then if we go to calculate... TS node app graph calculate. I don't know how much of this is compilation and how much of it is like actually, make high-speed parts. Tech. This takes a while. I wonder, yeah, if there's did that just change? I'm gonna pretend I didn't. Oh, is it because we matched the strings? Okay, anyway, make... Okay, yeah, no, this isn't bad. I mean... Yeah, so one machine takes 180 aluminum bars and 90 polymer bars. Let's see. Okay. So I wonder how I'm calculating the number that comes after aluminum ore. It's very interesting. Oh yeah, because aluminum is 2 ore to 1 bar. Yeah, so it's 360 ore, which is N miners. Okay, that's cool. Okay, so let's save and let's get out of here. night.